Hello from Jones Engineering, ComAp's distributor for China. Today we're excited to show you the powerful new 2.1 firmware for ComAp's InteliNeo 530 BESS controller. We are going to focus specifically on off-grid and rental applications, meaning there is no grid connection. Instead, we're pairing the BESS with a diesel generator for a seamless standalone power system. A quick note before we begin. We've included timestamps in the show notes below. Please feel free to check the show notes and jump directly to the specific sections you're most interested in. I've also added some links to my previous tests that were done with this BESS. Before we dive into the test, a quick bonus feature for the 2.1 firmware. It now allows for DC solar integration. If your setup includes PV panels, the 530 controller can now directly read the power coming from your solar array. Let's walk through our test setup. Here we have a 100 kVA, 200 kWh BESS. The InteliNeo 530 acts as the power management system, or PMS, handling everything from energy flow to monitoring alarms. One important technical note: for this system to work, your power conversion system, or PCS, must support Virtual Synchronous Generator, or VSG technology. As long as your PCS has this feature, ComAp's proven synchronization algorithms take over to make the entire microgrid incredibly stable and resilient. The BESS is connected to a test load bank. On the generation side, we have an 80 kilowatt Shanghai diesel genset, and it's currently running on ComAp's InteliLite MRS16 controller, so it does not need to be a parallel genset. And here is the major advantage: you can use any genset controller from any brand. Because it's a single running genset, the 530 controller doesn't need to directly control the engine speed. All the system needs is a simple remote start-stop signal and a ready-to-load signal sent back to the 530. To measure the generator's load, the 530 reads data via Modbus TCP from a standard power meter. Alternatively, you could use ComAp's mains controller here. This would give you the flexibility to easily adapt the system to a grid parallel system in the future. Finally, inside the BESS, we are using a standard air circuit breaker. Because the synchronization is handled so precisely by the controller, you don't need an expensive STS breaker. Standard cost-effective hardware is all you need to do to get the job done. We will be demonstrating two modes: BESS Priority and Genset Priority. And we will be explaining a feature of our Genset Priority mode, which is the boost mode. BESS Priority mode. The BESS is loaded. We are trying to simulate the BESS running to low SOC, or low charge, so we let this run for a little bit. Because we don't want this demonstration to be too long, we have simulated a situation where the low SOC is triggered. So, we have low SOC triggered and remote start signal is sent to the genset. I'm manually switching to the synchroscope screen for better viewing. On a running system, you don't need to be switching to the synchronous screen. The system will still auto-sync. The genset has started, now at idle speed and ramping up to run speed. When the genset is near 50 Hz, the Neo 530 will actively adjust the voltage and frequency to find the synchronous point with the genset. When sync conditions are met, breaker will be closed by the Neo 530. Then the BESS will be transferring the load slowly to the genset. The target is to run the genset at 80% nominal power. The nominal power of the genset and the optimal power level, which is now set at 80%, has to be configured into the Neo 530. If the load is lower than 80%, which is 64 kilowatts for this demo, the Neo 530 will request the genset to charge the BESS. If the load is higher than 64 kilowatts, the Neo 530 will not request the genset to charge the BESS. By varying the charge-discharge amount, the Neo 530 can effectively maintain the genset loaded at around 80%. This will let the genset run at optimal fuel consumption. And the genset running at an optimal load reduces the issues related to underloading of a genset, such as excessive carbon buildup. We are trying to show that we are charging the BESS to high SOC or high charge level, so this will take a little bit of time. As we do not want the demonstration to be too long, we have simulated a high SOC reached. So high SOC is reached, the Neo 530 is transferring the load from the genset to the BESS. Transfer completed, breaker will open. Genset will be remote stopped. Genset goes to cooling. Now we're switching off the load. And genset is stopping. So this is BESS Priority mode. Genset Priority mode. In this application, the load is supplied via or through the BESS all the time, so we will start the BESS first. Now we're applying 18 kilowatts of load. We will switch to Genset Priority by pressing the button to start the genset. The MRS16 is in man mode by mistake, so the remote start signal is not working. The MRS16 is switched to auto mode by computer, and the remote start signal, which was already sent by the Neo 530, immediately goes into effect, and the genset starts. When the genset is near 50 Hz, the Neo 530 will actively adjust voltage and frequency to find the synchronous point with the genset. When sync conditions are met, breaker will be closed by the Neo 530. Load transfer is completing, genset is taking all the load. When load step is applied, the BESS will take most of the step load immediately, and then the BESS will transfer the load back to the genset, and the BESS remains at zero charge discharge. If you have load off, the BESS will go into charging first to soften the load off effect to the genset, and then the BESS will return to zero charge discharge. We will be doing several load on, load off to demonstrate how the system assists in handling step loads, so the genset is less stressed by high step loads. The system could be set up for the genset to charge the BESS a little bit all the time, so the BESS will not go into low SOC, but we did not set up this function for this demo. Boost mode. We had programmed a boost mode that is activated after a 5-second delay when load exceeds 80% of the genset nominal power. This means when load exceeds 80% of the genset nominal power, the system will automatically switch to a balanced mode, whereby the genset and BESS will take the balanced ratio of the load. This means while running in boost mode, the maximum load of the system is the genset nominal power, which is 80 kilowatts in this case, and the BESS maximum output, which is 100 kVA. Note at this point the load is already higher than the nominal power of the genset, which is 80 kilowatts, or the BESS maximum output of 100 kVA. But please use the boost mode with caution, as the BESS is a battery and can only run on high load within a certain time, and we need the genset to recharge the BESS. For this setup, when load drops below 25 kilowatts, after a 5-second delay, boost mode will be deactivated and the system returns to Genset Priority and will be in zero charge discharge and assisting step loads. When Genset stop button is pressed, after a 30-second delay, the remote start-stop signal will be deactivated and Genset will start to stop. After 30 seconds, the breaker opens and the genset is stopping. This is Genset Priority mode. As you can see from the demonstration, ComAp's InteliNeo 530 BESS makes managing an off-grid BESS and genset integration incredibly smooth and reliable. By combining standard cost-effective hardware like standard air circuit breakers and any brand of genset controller, with ComAp's advanced synchronization, you get a highly resilient power system that is perfect for rental and off-grid applications. If you have any questions about the new 2.1 firmware, or if you need support for your own energy storage and microgrid projects, please reach out to ComAp or leave a comment below. You can find links to previous demos and the description of this video in the show notes below. If you found this video helpful, please give it a thumbs up. Thank you for watching from all of us here at Jones Engineering. Thank you.